Okay, so the things that you guys need to know to do this. First of all, the word rational. All you need to think of when you think of the word rational is think of fraction. And rational specifically refers to fraction with variables. So these are going to be the kind of things where you have x's in the denominator. And when you're adding fractions, a couple of basics on that. First of all, also expression means simplify. It means that we don't really have equations. So the biggest thing, as I kind of introduced the first example, is going to be factor then cancel. And you guys should have at least enough of a sense to know now, very instinctually, that you can't just start taking your pencil and slashing things that are remotely in common. That doesn't make sense. This refers back to the idea that if I have AC over BC, and it's being multiplied, then that's going to be the same thing as A over B, provided that C is not equal to 0. So that's the idea behind slashing, but the operation right here matters. And this kind of manifests itself more when you have parentheses. You see this a lot when you have parentheses, because parentheses mean that you have factored. Is this true? A plus C is equal to B plus C implies that A over B is equal to C over B. If that were true, then I could say that about 7/8 and say 7 plus 1 over 8 plus 1 is equal to 8/9. Sorry, that's a bad example. That's equal to 7/8 because it could subtract the 1. But that would imply that 7/8 is equal to 8/9. And by logic, you could keep that going on and on and on again. So the same mistake holds true. I see this when you cancel like that. I see that as a mistake in order of operations. Because what you're doing is you're using canceling, which is a division operation, to undo addition, and that doesn't make sense. It's very similar to when I have this, where I have x plus 5 is equal to 25, and I have someone divide by 5 and say that x is equal to 5. Like, that's not the right operation to undo what's happening. So as a first step in this problem, you're looking to factor. And you're looking to factor the numerator by difference of squares. You guys should remember what that becomes, x. And the denominator, you're playing that game with the 8 and trying to figure out what multiplies to -8 but adds to -2. And that would be a plus 2. Then, if you want, you're never ever required to do this. You can do a light line showing what you've canceled, but please, whether you write that or not, rewrite it as x minus 2 over x minus 4. For some reason, when you rewrite it without the parentheses, you can kind of forget that you can't cancel anything here. So I will have a group of kids ranging all the way from freshman algebra 2 honors to even senior, like they will at some point write that. And it's not what this is. Don't make that. That's a final. This also makes one critical assumption, and this is critical from a pre-calculus thing. If we're truly going to call this course pre-calculus, then there has to be something that makes this different from an algebra 2 problem. And the different part is that by canceling the x plus 2, you've actually lost a piece of information. What have you lost by canceling the x plus 2? This represents an expression with lots of possible x values. Input, output. It could potentially be a function, but it represents all these things that we could plug x to and get this number. There is one value of x that I cannot use, and that's -2. I know x can't be 4, but I don't need to state that. That's a little bit obvious by looking at this version here. I know x can't be 4. But I don't know by looking at that x could not have been -2. I would have to reintroduce that. I canceled the factor that had that piece of information. So I wouldn't know that. So I have to say it now. And this is considered a little bit more simple than what was right above it, even though what's right above it says exactly the same thing. It's almost like you have to step away and stop thinking about simplifying as just kind of being this process and think about it as you're expressing the same idea in a different form, in a form that's a little bit easier. Now, your book and most books talk about things like, from this point forward, we're going to assume that any variable expression we plug in is going to be not give you a 0 in the denominator. And they do that because in first lessons like this one, you don't want to miss the whole point of it. You don't want to miss the forest for the trees. Like, you don't want to get so concerned with these details that you forget why you're doing this, or you forget what you're doing. So just be wary of that. Okay, second one. X squared plus 2x minus 8 over x squared minus 4. Same idea. In this one, you're going to get an x plus 4 and an x minus 2. X plus 2, x minus 2. When you cancel those, you're left with this. What value could x not have been based on what you canceled? Yeah, so you're going to say an x can't be 2. Do not tell me x can't be negative 2. I know that. The problem says that. Like, that's implied. You don't need to say it because that's like describing something that's already readily apparent. Go ahead and try to plug in negative 2. You wouldn't be able to do it. You divide by 0. But if you tried to plug 2 in, you wouldn't know necessarily that the original equation, or sorry, the original expression would not let you plug 2 in. That's why you're writing this. You're writing that because back way up here, you would not have been able to plug 2 in. So if you're going to say that the final version is identical to the original one, it also can't plug 2 in. So you kind of just have to say that. Okay, number 3. Every year, no matter what I'm teaching, I get people that forget how to factor a sum or difference of cubes. It's okay if that's you. You look at the numerator and you see that it is a difference of 2 perfect cubes. You have an x cubed and you have a 27 that is 3 cubed. So off to the side, I want to kind of remind you guys how to factor 2 things. X cubed minus y cubed and x cubed plus y cubed. We have a factoring pattern for difference of cubes, and we have a factoring pattern for sum of cubes. Do you remember how to start this? There's nothing you can necessarily take up, but x what?
X cubed and 27 are both like cube numbers.
They are, yep.
Yeah.
So I'm just kind of review. The first thing that you would write is a binomial, and it's the cubed roots of each of them. That would be x minus y. But the second thing you write is a trinomial. First, it's the square of the first one. Then it's the product of the 2 of them. Then it's the square of the last one. And there was an acronym that helps you remember the signs. Do you remember what that stands for? Same, opposite, and positive. Same, as in it's the same as what came before. Opposite, as in this sign here should be the opposite of what came before. And then always positive means the last one is positive. A sum of cubes factors virtually identically with the exception of the sign. So I'm going to write the same terms in the same place. Same means it's a plus. Opposite means instead of a plus, it's a minus. And always positive means it's the end. I want to show you one way to write this that actually combines these two into one statement. Whenever you have x cubed plus or minus y cubed, whichever one you have, the factoring pattern is this. You have x plus or minus y, which means that if the plus is there, then the other one's a plus. If the minus is there, the other one's a minus. You have x squared, xy, and y squared. But does anyone know a symbol that means the opposite of if it's plus minus? This is actually in keyboards. I did not know what this symbol meant until I started looking at this. And like, oh, that's what that symbol means. There's a symbol minus plus. where you write the minus on top and the plus on the bottom. And what that means is that if this one is a plus, this one's a minus. And if the first one's a minus, then that one's a plus. It's kind of a matching game. And then the last one is always positive, so you always write a plus there. This is sort of like taking these two and just combining it into a single statement. And this means same, opposite, and positive. So can you use that to factor the x cubed minus 27? Realize that it does not factor into this. I get a lot of people who want to put that down. That is not how it factors. Do not do that. Binomial and trinomial. The binomial is just the cubed roots of each of those, x and 3. The trinomial, square that. You get x squared. Multiply them together, 3x. Square the 3. And then same, opposite, always positive. Same, minus, same as what it was originally. Opposite of the minus is a plus, and always positive gives you that. Divided by, what do I do here? Caleb? How? What can I factor out there? And then you have x squared plus x minus 12. That can go further. Yeah, logically, you're going to know that an x minus 3 is probably going to be one of the factors. If it wasn't, you really wouldn't get anything canceling. What's the other factor? The x minus 3's go. And you get x squared plus 3x plus 9 over 3 times x plus 4. What did I cancel? From what I canceled, what could x not be? 3.
On the second step on the top, when you're like factoring out like the x cubed minus 27.
What I was doing to get from here to here,
Yeah, like what you were saying.
I was matching it with this pattern right here.
Oh.
Okay, that's why I went over the whole difference of cubes.
Yeah, but I don't get.
A difference of cubes always factors into a binomial. A binomial is a word that means a 2-term polynomial, and a trinomial, a 3-term one. When I look at the x cubed, I use that to generate that x. Look at the 27, I use that to generate the 3. I know that it comes down, the first factor is going to be the same sign as the one originally, with an x and a 3. Then I use that to generate the second factor. So once I have the first factor, I'm going to kind of take the x and square it. I mean, x times x would have to be x, or x times x squared would have to be x cubed. I look at the last ones. I would need a positive 9 there. And then the 3 and the x give me a 3x in the middle. I kind of think of the middle as being a product of those two, but it has to be opposite signs. So it's a little bit of practice and kind of playing around with doing it right. But once you get experienced at it, it shouldn't be too bad. Okay. Number 4, xa plus 3x minus 4a minus 12 over xa minus 2a plus 3x minus 6. So numerator, this is a factor by grouping, and you're looking to see, do these have anything in common that you can take out? Yep.
Can you rearrange the numbers on the bottom so that
You can. If you want to put the x's together, you absolutely can.
you just take out the xa?
You can, not the xa, because it's addition, remember? It has plus signs next to it. You've got to pull it apart and factor it. But, and Parker, we may not have to. So look at what the first two have. If I pull the x out, I get an a plus 3. What about these two? Even better. Negative 4, giving you an a plus 3 over. If I keep the denominator exactly how it is, I can pull out an a and get an x minus 2 plus a 3, which also gives me x minus 2. And then your next step is to look at the entire numerator and see what can you pull out of the, like both sides of that. What can you pull out of that, this and this? An a plus 3. And what you're left with when you pull out the a plus 3 is the x minus 4. Divided by denominator, you can pull out x minus 2, and you're left with a plus 3. Then you can simplify. A plus 3's go, and you get x minus 4 over x minus 2. There's no way to predict that that's what would have happened based on the original problem. You have to make sure you factor it correctly. Okay. I'm going to circle that and just kind of move on from this one without worrying about the domain restriction. Joss?
Oh, I was actually going to ask that. Would you say that a can equal negative?
If you wanted to, you would say a can equal negative 3. Yes. Because that definitely has been lost. What does that simplify to? It can. Wouldn't be 0. Close. What's 5 minus 7 over 7 minus 5? 11 minus 6 over 6 minus 11. Do you guys see that 3 minus a and a minus 3 are opposites of each other? Like whatever you subtract in one way, if you subtract the other way, you're going to get the opposite number. The way to prove that is just to pull a negative out of the numerator and make it negative a minus 3 over a minus 3. Then when you cancel those, you get a negative 1. Yep. And if you want to be completely clear, you'd say a cannot be equal to 3 because you canceled that. You lost that bit of info.
What would happen if it was just a minus 3 over a minus 3?
Wouldn't be complete.
Would you do 0 too?
What? You can't say it's 0. A number divided by itself is 1. A number subtracted from itself is 0. But if I took 7 over 7, I can't say that's 0. 0 over 0 is indeterminate. It means we don't know. Okay, next one. And let's move on to some more difficult ones. Take a 2 out, you get x squared minus 4. What can you take out of the denominator to make it in the same order? Negative. And then you're going to have an x minus 2. And then if you factor that numerator out, you're going to get x minus 2, x plus 2 over negative x minus 2. Cancel the x minus 2's. Go ahead and just move that negative to the numerator. Negative divided by 2 divided by negative would just be negative 2. But don't feel like you have to multiply that in. Our goal has been to factor. Peter, I hope you were doing something relevant. What I would say from this is x is not equal to 2 because we canceled that 2 out. So okay, next one. This one's a little bit more of a pre-calculus question. Find the domain of q of x is equal to x over 2x squared minus 8. This is going to introduce one of the inequality symbols we have not used hardly ever. We've used it a little bit here, but we haven't actually worked with it. Do you know what that symbol is? The inequality symbol we have not really used. We've used that. We haven't used that one. Yeah, so what do I want to set not equal here? If I'm going to find a domain, what has to be true? What's the number one rule of math? You cannot divide by.
0.
So what can't be equal to 0?
0.
Is it negative 2x plus
2x
8?
squared minus.
It has to be the whole denominator. You can't, to say negative 8 is not equal to 0, I'd say yes, I know that. But I'm looking for the x values that make the entire denominator equal to 0. So you work with not equals just like you work with equals. If I divide both sides by a 2, I get this. And if I factor both sides, I get this. And that means that x cannot be equal to plus or minus 2. I can call that my domain. This last one that we're going to do has a special name. It's called a difference quotient. It's an operation done a lot in calculus, and being a pre-calculus class, that's why it's being introduced now. In this problem, f of x is equal to 4x plus 2. So if I'm finding that, I'm going to do a 4x plus 2 minus, what's f of a equal to? If f of x is 4x plus 2, then f of a is 4a plus 2 over x minus a. All this is asking you to do is simplify this. So you have 4x plus 2 minus 4a minus 2 over x minus a. The 2's cancel, and you get 4x plus or minus 4a over x minus a. Factor the numerator. And they cancel, and you get 4. The last thought I want to leave you, Ben did ask a relevant question, I know, which was, what is 0 over 0? That question is actually approached a lot in calculus. This is what happens when x and a are the same thing. You actually are able to kind of cancel them out, so that's coming. Okay, I'm going to put homework up, and I will see you guys mañana.